Hey there. In this tutorial we'll be covering how to create geometric dimensioning and tolerances and put them in Creo. For this tutorial we'll be using the stop-based file, and I've made this file public to you. It's on the shared drive, Classrooms CAD Engineering 2. Inside the Engineering 2 folder you'll have a folder in there called stop-based. Copy the entire stop-based folder and place it in your Creo working directory. Inside that folder, the stop-based folder, will be one file. It has a part name of 148-478-005-136, and the common name is stop-base. So geometric dimension tolerancing is done in Creo through the drawing. So we need to create a drawing for this part. Remember, all drawings should be the same part and common name as the drawing of the part itself. So we're going to make this the exact same as the part. Base. Okay. Click OK. Part is selected. We want an Imperial multi-view template, and we'll create the template. Okay. All right. Before we add geometric dimensioning, I'm going to go ahead and just clean up this drawing some, remove some things we don't need. And I'm going to move some of these dimensions to views they're better represented on. All these diameters and radiuses are going to be better represented in that top view. So I will move them. And I'm going to move some of these dimensions so they are not cluttering the front view. And then finally, we are going to arrange our extension lines. Flipping these arrows so it's cleaner. Alright, and we're set. Time for some tolerancing. Oh, I forgot one extension line. Now time for some tolerancing. Okay, so on canvas, all the GD&T instructions are below. They're all adding to this part, drawing of the part. I'm going to go them one by one. I might skip around a couple of these. We're going to start with making all dimensions that are not tolerance dimensions basics. So anything that's not toleranced. And I know that because I've done this before, but if you read it, it says that this diameter is not toleranced, and neither are all these basic dimensions here. The only thing that are toleranced is the 0.630 and the radius. So we're going to go ahead and make them all basic dimensions. Select them so they turn green. Hold right click, go to Properties, Display, set it to Basic. We're not tolerancing these dimensions, so we're going to set them to Basic. Again, click once, so it's green, so it's selected. Hold right click, go to Properties, Display, Basic. Okay, good. Next, datum identification. We're going to make the very top surface datum A. We're going to make this surface here datum A. So to do that, we go to the Annotate tab. Here's our geometric tolerancing and our datum selection. So we're going to make this top surface datum A, so that's better done in this front view, selecting that top line. Click Model Datum. We will name it datum A. Display datum square with triangle indicator. We will select on surface, and we want to make sure that it's not this it's selected, but it's just that top line, meaning that top surface. So we'll click that, and it'll drop in our datum placements. We should be good. Click OK. Now we can go ahead and reorganize this some so it's a little bit cleaner. And we don't need this to indicate twice. We're just going to remove this one. Okay. Next, we're going to make the 0.63 diameter hole with datum B. Before I do that, I want to tolerance tolerance and set the control box, and then I'll place the datum because the datum will attach to the control box. So I'm going to do that last. So I'm going to skip to this step. The size of the hole must be a limit tolerance of 0.68 to 0.63. Okay, so I'm going to select this dimension. Hold right click, go to properties. Under tolerance, we're going to change it from nominal to a limit. The upper is 0.68. The lower is 0.63. In addition, it's going to display it in this format. We do not want it that way. We want it the way we did it in Engineering 1, which is a ISO tolerance display style. So under display, check that box. Should be something we're used to seeing. And we'll click OK. Our limit tolerance is set. Now we need to add a control box for the position of that hole. The position must be within a 0.035 diametrical tolerance zone and maximum material condition relative to datum A. So we'll start with creating the control box. Go back to annotate, geometric tolerance. Okay. It says the position must be 0.035. Okay. So here are your symbols. If you hover over them, it says the name. We want position of 0.035. That's under tolerance value tab. 0.035. Okay. Must be within a 0.035 diametrical tolerance zone. So we need the diameter symbol. So we go to the symbol tab, diameter. In addition, it also says at maximum material condition. This is before talking about the relative datums it's associated to. So that means the maximum material condition needs to go within the tolerance value. So we're going to material condition, maximum material. If it was placed after the datum reference, we need to go to datum reference tab. We set A, then you would set the maximum material here, but we do not want that. Okay, now we're going to go ahead and reference it. This is going to be an edge. Okay, so we're going to select the edge, and then we're going to place it, and we're going to different things we can attach it to. We can just drop it anywhere. We can create a leader to it. We can attach it to a dimension. We want to attach it to this dimension that we already created. So dimension, and we'll select it, and it drops it in. Click OK. Done. All right, now we can go ahead and call that hole datum B. Make the 0.63 diameter hole datum B. So to set the datum, click Model Datum. Name it Datum B. All right, we're not going to be selecting on surface this time because it's the hole itself. So we need to define it. It's going to be a through hole. The cylinder. Once cylinder is selected, we need to click the hole itself. Okay, so it's selected. We will then click Done. We're now display it. It drops it down there. So we want to change that. We want to attach it to this. So we'll click Dimension, and we'll pick the dimension. And it'll drop it there, and click OK. And you can reorganize this if you want to. Okay. I'm going to move that back because I don't want that close to the view. Okay, next. So datum C. Set the lower top surface of datum C. We're going to set this face here to datum C. That's best done in the front view. So model datum C. It's going to be a surface this time. We will click the surface. So it's that edge. If we have problems, click it over here. Place the dimension. It's a little hard grabbing the line. It's easier to grab from the right view. We'll click OK. We're going to use the front view datum though. So we're going to end up deleting the right view datum indication. Okay. And then we'll delete this, erase this one. We don't need two of them. Okay, good. Next, we've done our holes. The flatness of data A must be within a 0.05 tolerance zone. Okay. The flatness of datum A. Okay. I'm going to add geometric tolerance. Flatness of datum A, 0.05 tolerance zone. No maximum material. Okay. We're going to select the datum this time. It's going to be datum C. We're going to click OK. We place it on the datum instead of the surface. We're going to have to rearrange these now since they're overlapping. Okay. Next. Done the holes. So the front face of the part, we're going to make the profile of the surface must be within a 0.045 tolerance zone relative to datum C at max material condition. So the profile of the surface, and this is going to be the front face of the part. So it's going to be this face here, front face. Geometric tolerance, the surface profile, I believe it was. The profile of the surface, yep, surface profile. Must be 0.045. Tolerance zone relative to datum C at maximum material condition. Okay. We're going to add the reference to C. C will be maximum material. Okay, we're going to go ahead and select the surface. This is going to be best done indicating it on the front view. So we can't do this entire front surface here, or in the top view. We can't do the entire surface in the front view, so it would be easier done on the top view. Or the right view. Actually, the right view is going to be easier because then it's indicating both instead of a single one. So we're going to click the surface. And we're going to place it with the leader. Arrow head. And we're going to drop it down. Place. Arrowhead. Done. With leader. Done. We're going to once push it out that way. It's okay. And then click down the wheel to drop it. So it took me a second there. The problem was when I had to drop it, the leader, automatic, I had to hit the surface itself first. That's what was giving me problems. So, okay. All right, next. The right face of the part, the profile of the surface would be in a 0.05 tolerance zone relative to datum A and C at maximum material. Tolerance. Profile of the surface again. Profile of the surface. Tolerance value is 0.05. Okay. 0.05 relative to datum A and C. The C is at maximum material. A is the basic. Secondary is C. C needs to be maximum material. A is basic, secondary, and tertiary. These are the options. Alright, time to place it. So this is the right face of the part. The right face of the part would be here. So that is best done on the front view. We may get a little clumped up here. We'll make it work. Select the entity. Is that surface? We're going to place it with the leader, arrowhead. Click again. We'll probably attach it up here. We'll drop it. All right, we're going to need to organize this a little bit. And I think what I'm going to do is I'm going to move this view, unlocking it, and I'm going to slide it this way some. Give myself some room. Lock the view again. What I'm going to do, actually, I'm going to move this A. Just so I can reorganize this a little bit better. Things get clumpy sometimes, so reorganization. Alright, that looks a lot better. And what we could do, even, this dimension, this tolerance can be placed on this dimension if you want to, and if you wanted to do that, you can place it with the dimension itself, if you so choose. Okay. Next, last one. The slot and arc on Datum C. So the profile of the servers of the arc must be within a 0.05 tolerance zone relative to Datum C and maximum zero condition. Okay, 0.05 is the profile of the surface. 0.05, it's relative to Datum C and maximum material. C and maximum material, there's no secondary. Okay. We're going to go ahead and select this surface right there. We're going to place it to the dimension. Click OK. And we should be set. I'm going to save my part. Stop base. Model is not regenerated. If you get that error, we need to regenerate the part. Regenerate the part is this button here. Regenerate active model. So in other words, because we're making these changes in the drawing, it's pushing these changes to the part, but it wants the part to be regenerated. In other words, we need to go back into it, and you can see now the part has our datums that we created on it. So it pushed all this information to the part itself. Okay. Last thing, let's make sure this drawing is set. We're missing some center lines. We're going to make sure we select those. So I click on the view. Going to show model annotations. We need to add these center lines. Apply. Add it to the front view too. And finally the right view. There we go. And we should be set. I'm missing model annotation here. There we go. Oh, I'm hitting cancel. Make sure you don't hit cancel when you add it. Click apply. close it out. Okay. And we're done. Ready for PDF. Save one more time. I'm going to go under Save As, Export, Export PDF. I'm going to put it in the same folder. That way everything's together. And it's created the PDF. And it should pop up here. Looks good. And that's it.